Hi there, folks. Today we're looking at some of the basic rules of exponents here, just how exponents react in certain situations. And most of this should be review. We've talked about some of this perhaps, but remember, exponents always kind of do their own thing. Regardless of the operation, they're doing something a little bit different than what the operation is presented as. And so let's think of this from the perspective of operations. If we talk about operations in terms of order of operations, we're looking at this thing called IRMDAS, right, is the way I like to refer to it. And so we're going to start at this back end with addition and subtraction. Then we'll talk about multiplication, division. Then we'll talk about exponents and roots and kind of how the exponents react when we're doing each of those operations. So first of all, adding and subtracting terms. In order to add and subtract terms, we know we need these things called like terms. Like terms are where you have the same variables with the same exponents. Basically, those pieces have to match completely. And when we add those things together, we just add the like terms in terms of adding the coefficients, adding the numbers out front. But the exponents just stay the same. They stay the way they are. See, we have to have these things that are identical. And after we add them together, they stay identical. And so looking at that from the perspective of order of operations, when you add, you don't do anything with the exponents. See, there's nothing behind addition there, okay? Subtraction, same thing. There's nothing behind subtraction here. So when you subtract, you literally do nothing with the exponents. They stay the same, all right? And so when you think about that from the perspective of order of operations, it's just one step back, all right? If I'm doing addition and subtraction, the exponents are one step behind. They're not doing anything, okay? And so it's an easy way to kind of remember that if you remember order of operations. For example, if I look at something like this guy, I've got 4x squared plus 5x squared. Well, first of all, are those like terms? And the answer is yes, they are like terms. I have the same variable of x. They each have the same exponent, x squared. So I just add these, ignoring the variable part. If I had 4 plus 5, that would be a 9. So I write down a 9. And then the variable part, the exponent stays the same. When I add terms, the exponents don't change. It stays as an x squared, and that's it. Okay? Same thing here. I've got 17y to the fourth minus 6y to the fourth. They both have y's. They both have fourth powers. So the variable part is identical. They're like terms. I subtract. 17 minus 6 is an 11. And then when I subtract, the exponents stay the same. They don't change. They don't do anything. So y to the fourth. And then when I look at this last example, I've got a 3x squared plus a 7x to the fifth. Well, one has an x, the other one has an x, but one has an exponent of 3, the other one has an exponent of 5. I can't do anything here. I can't add these together, all right? I can't do anything with this. I have to leave it the way it is because those are not like terms, okay? In order for the exponents to do nothing, they have to be the same, all right? Or else how do I know which of these exponents to use, okay? So when you add or subtract, you don't do anything with the exponents. Let's talk about multiplication division. Again, let's think of this from the perspective of IRMDAS, of order of operations. So here I go. I'm writing it again. We just talked about that when we add, we do nothing with the exponents. When we subtract, we do nothing with the exponents. It's one step back. So let's talk about multiplication. Multiplication, if I go one step back in order of operations, you see that I'm at addition. Well, guess what? That's what the exponents do. When I multiply terms, I add the exponents. Division, one step back in order of operations, well, that's subtraction. All right, so when I divide, I subtract the exponents. And again, this is just a nice, easy way to remember it. All right, when I add or subtract, the exponents are doing nothing. When I multiply and divide, the exponents are adding and subtracting. Okay, it's one step back in terms of order of operations. So when I multiply, I add the exponents. When I divide, I subtract the exponents. So if I look at this guy, ready? 3 times 6, that's an 18. And here's the thing, the numbers that we're dealing with, if I had 3 times 6, well, that's not going to be any different than if I have 3 times 6 in this context, okay? If I had 3 times 6 all by itself, it's 18. If I have 3 times 6 in this context, it's 18. The thing that does something different is the exponents. When I multiply b to the 10th times b to the 21st, I add the exponents. So that's going to be a b to the 31st. And that's it. If I look at the next one, same kind of thing. I'm multiplying. Well, 2 times 5, that's not any different than it's always been. 2 times 5 is a 10, so I write down a 10. But when I multiply, I add the exponents. So here I add the exponents. That's going to be an a to the negative 6th. Okay? And yeah, it's okay to have a negative exponent. We'll look at later how to deal with those. If you remember that now, remember you send that to the denominator, so it would actually get written as 10 over a to the 6th. I'm going to leave it the way it is for right now, though. Okay? If I look at the next one, it doesn't matter that these are numbers here, all right? And here's the thing. I could write 10 to the 6th power as 10 a bunch of times, but let's just use the rules of exponents to simplify this thing. And so again, when I'm multiplying, I can add the exponents. That's going to be 10 to the 15th. And I could leave it like that. And obviously, I could punch that into my calculator, that kind of thing. The reason I like to throw 10 out here is because that relates to scientific notation and how we'll deal with operations in scientific notation using rules of exponents. Okay? And then down here, division, we're just going to subtract the exponents. Again, 10 divided by 5 is 2, like it's always been. But now I subtract the exponents, that's a to the 1st. And you can write the little 1 there. We don't have to write the 1. We can make it an invisible. All right? Because when a is by itself, it's automatically a to the 1st. Okay? The next one, 6 divided by a negative 3 is a negative 2. Again, I subtract the exponents. That's going to be an x to the 8th. That is a terrible looking 8. Let me try again. I can do better. I believe in me. Oh, not much better. The next one, negative 2 divided by 2 is a negative 1. And then I subtract the exponents, y to the 2nd. Okay? But again, it's all just one step backwards in terms of order of operations. When I'm adding, subtracting, I don't do anything with exponents. When I multiply and divide, I add and subtract exponents. Okay? Let's talk about exponents roots. Once again, let me go back to order of operations. In order of operations, ready? My good buddy Irmdas. I'm going to write it one more time here. So once again, we just talked about, hey, everything's one step back. So addition and subtraction, I don't do anything. Multiplication and division, I add and subtract. So now let's take exponents and roots one step back. Ready? Exponents, I'm going to multiply. Roots, I'm going to divide. All right, and we kind of already talked about that one as we were simplifying square roots and cube roots and those kind of things. But that's where all this comes from. All this is related, and it's easy to remember if you think about it from the perspective of order of operations. It's one step back. Addition and subtraction, I do nothing. Multiplication, division, I add and subtract. Exponents and roots, I multiply and divide. Okay? So when raising something to its power, I multiply the exponents. When taking a root, I divide the exponents. Okay? If I look at something like this guy, I've got x to the 10th power and then raised to the 3rd power. So if I raise that whole thing to the 3rd power, see, it's an exponent being raised to another exponent. Well, this is where I multiply the exponents. So that's going to be an x to the, sorry, let me switch back to blue here, x to the 30th power. That's it. Okay? If I look at the next one, this is where students really stumble. It's that 5 out front that we really stumble with. If I were to ignore this guy, though, for a second, if I had this 5 to the 2nd power, all right, we wouldn't even blink. We'd have this done already. 5 to the 2nd power is 25. So I do that the same way I've always done it. That's a 25. But now exponents, even though I'm doing an exponent here, even though I'm raising it to the 2nd power, exponents do something different. They're one step back. The exponents get multiplied. So that's a to the 6th power. Okay? Next one, negative 3 to the 3rd power. I treat that the same way I've always done exponents. Negative 3 to the 3rd power is a negative 27. But exponents do something different. So the exponents get multiplied. That's an x to the 21st. Roots work the same way. Remember, I divide the exponents. So here, 30 divided by 6, that's going to be an a to the 5th. All right? If I look at the next one, again, the number out front, well, that acts the same way it's always acted. The cube root of 8 is a 2. And now I divide the exponents. The exponents get the different operation. Okay, so when I divide those, that gives me an 8. And then the next one, the thing about the square root is you have to remember there's a little bit itty-bitty 2 here. I can't see it, but I know it's there. All right. So now the square root of 49, that's just a 7. We're used to that one. But now I divide the exponents. That's a y to the 6th. Okay? So rules of exponents. When we're doing operations and exponents are involved, exponents are always one step back. Okay? When we're adding and subtracting, the exponents don't do anything. They stay the same. When we're multiplying, we're adding the exponents. When we're dividing, we subtract the exponents. When we raise things to a power, we multiply the exponents. And when we take roots of things, we divide the exponents, okay? That's our basic rules of exponents in terms of order of operations. So as we're doing operations that involve exponents, we just have to remember they're always one step back, okay?